Hello everybody. Okay, so in this video we're looking at proof by induction. Specifically in this video we're looking at proving a series by induction. So, so what is proof by induction? So proof by induction is just a method of mathematical proof, okay? So like, we don't get these like theorems and stuff like out of nowhere, right? You have to go through like rigorous like proofs and like you have to be signed up, like, you know, like maths is proven, you know what I mean? Once something's proven, it's solid, you know? So proof by induction is just a proving method we have. It's called a rolling proof method, right? Where we prove that the first statement in a set of infinite statements is true, then prove that if any statement in an infinite sequence is true, then so it is for the next statement. So we think of it kind of like a stairs, right? So where we prove we can walk on the first step, grand. So we can prove the first step. That's easy enough. Then we just prove we can walk on any step, right? We prove that we can walk on any step. We call it the step case. We're kind of generalizing it. So we can walk on any step. Then if we can prove we can walk on the step right after that, well, that just means we can walk on any step. We can do any step. We can complete any step. This formula or series or whatever works for whatever length it is. So it is very important to follow these steps with proof by induction because you get the majority of your marks for just following the first like two steps. So first, you prove true for the smallest value of n in the question. It's usually n equals 1. Then you assume true for n equals k. You show it's true then for n equals k plus 1. So let's have a look here. Prove that 1 plus 2 plus 3 plus 4 up to n equals n over 2 times n plus 1 by induction. So I need to prove my left-hand side is equal to my right-hand side. So first we prove for n equals 1. So when n equals 1, my left-hand side will just be 1 because that's just my first term, is equal to 1 over 2 times 1 plus 1. 1 equals 1. Proven. Stunning. Next, we assume true for n equals k. So now where we have an n, I'm putting in k. There's going to be 1 plus 2 plus 3 plus 4 plus k is equal to k over 2 times k plus 1. Now the next step is we're going to show it's true for n equals k plus 1. And just make note of your assumption because you will be using it in your proof here. So nk plus 1, 1 plus 2 plus 3 plus 4 plus up to k plus 1 is equal to k plus 1 all over 2, k plus 1 plus 1. K plus 1 plus 1 will just be k plus 2. So I know now, I need to now show that this is true. Well, using my assumption, 3 plus 4 plus k plus k plus 1 is equal to k plus 1 all over 2 times k plus 2. Using my assumption here, I can rewrite 1, 2, 3 all the way up to k as k over 2 times k plus 1. So k over 2 times k plus 1, so that's to be k times k plus 1 all over 2 plus k plus 1 is equal to k plus 1 times k plus 2 all over 2. So now I need to make my left-hand side look like my right-hand side. So I need to add a fraction here. So I'm going to put 2 in the bottom. If I put 2 in the bottom, I need to put 2 on top. So I'm going to have k times k plus 1 plus 2 times k plus 1 all over 2 equals k plus 1 times k plus 2 all over 2. Factor out of k plus 1. K plus 2 all over 2. And that is equal to k plus 1 times k plus 2 all over 2. So I have proven my left-hand side equals my right-hand side. And then you put a nice little statement here. Statement is true for n equals 1. And assuming true for n equals k implies that it's true for n equals k plus 1. Therefore, by induction, it is true for all values of n elements of natural numbers. And that is proof by induction, right? It's 3 steps that you just have to remember. This goes for all our proofs by induction. Let's look at another example here. Proof by induction, 3, 7, 11, plus 4n minus 1 equals 2n squared plus n. So proof for n equals 1. So it's going to be 4 times 1 minus 1 equals 2 times 1 squared plus 1. That's going to be 3 equals 2 plus 1 is 3. Stunning, that's true. Assume true for n equals k. That'll be 3 plus 7 plus 11 plus 4k minus 1 equals 2k squared plus k. Now we show true for n equals k plus 1. The 3 plus 7 plus 11 plus 4k minus 1. Then my next term here will be 4k plus 1 minus 1, which will equal inside here 4k plus 4 minus 1 is 3. So this will be 4k plus 3 is equal to 2k plus 1 squared plus k plus 1. So we know it's true for n equals k, so we can rewrite the left-hand side. So again, using my assumption, I am gonna rewrite this as 2k squared plus k. I have here on my left-hand side 2k squared plus k plus 4k plus 3 is equal to my right-hand side here is just 2 times k plus 1 squared plus k plus 1. So, this is 2k squared plus 5k plus 3 is equal to my left-hand side here, which is gonna be 2 times k squared plus 2k plus 1 plus k plus 1. So it's going to be 2k squared plus 4k plus 2 plus k plus 1. My right-hand side is 2k squared plus 5k plus 3. And would you look at that? I've proven my left-hand side is equal to my right-hand side. So statement is true for n equals 1. Assuming true for n equals k implies it's true for n equals k plus 1. So by induction is true for all values of n elements of natural numbers. Right, so let's look at this one now. So this one uses sigma notation. So I want to prove that the sum from 1 to n of this sequence here, 2 to the power of or minus 1, is equal to 2 to the n minus 1 for all values of n elements of natural numbers. So let me rewrite this sequence here. So when or equals 1, it'll be 2 to the power of 1 minus 1 plus 2 to the power of 2 minus 1 plus 2 to the power of 3 minus 1 plus 2 to the power of 4 minus 1, 2 to the power of n minus 1 equals 2 to the n minus 1. That is going to be 2 to the 1 to the 1, so it'll be 0, it'll be 1. This will be 2, 4, 8, 2 to the n minus 1. So prove true for n equals 1. So when n equals 1, I get 2 to the 1 minus 1 is equal to 2 to the 1 minus 1. 1 equals 1. Ding, ding, ding. That's true. Assume true for n equals k. So 1 plus 2 plus 4 plus 8 plus plus 2 to the k minus 1 is equal to 2 to the k minus 1. Now we need to show it's true for n equals k plus 1. So I'm going to use my assumption here. So 1 plus 2 plus 4 plus 8 plus 2 to the k minus 1 equals 2 to the k minus 1. I can replace all this with 2 to the k minus 1. Sorry, this is 2 to the k plus 1 minus 1. Sorry. Oop. error here. Sorry. So, and then finally, so 2 to the k plus 1, so it'd be 2 to the k plus 1 minus 1, which is 2 to the k, which is equal to 2 to the k plus 1 minus 1. So I can exchange my first k terms here as 2 to the k minus 1 plus 2 to the k equals 2 to the k plus 1 minus 1. 2 to the k plus 2 to the k. Well, I have 2 2 to the k's now. And that can be written as 2 to the power 1 times 2 to the power k, which is 2 to the k plus 1 minus 1, which is equal to 2 to the k plus 1 minus 1. So therefore, I prove my left-hand side is equal to my right-hand side. So the statement is true for n equals 1, and assuming true for n equals k, implies that it's true for n equals k plus 1. We've proven by induction, and it's true for all values of n elements of n. And that is proof by induction for a series, and I hope this video was some help to you guys, and I'll catch you guys later. Bye!